Hey ho, ladies and gentlemen, welcome back to question number 3 on our 2019 fire paper. Tanya lists the positive integers in order, leaving out the integers that are multiples of 5. So her list starts 1, 2, 3, 4, skips 5, 6, 7, 8, 9, skips 10, it's a multiple of 5, 11, 12, 13, 14, skips 15, and we just keep going. So we've got one light bulb and then two written answers to this question here. So A, how many integers has Tanya listed just before she leaves out the sixth multiple of 5? Okay, well, there's nothing special about 6 there. So we could probably say something like, notice notice there are 4 numbers between any 2 multiples of 5. So, for example, 5 times n, the next number will be 5n plus 1, 5n plus 2, 5n plus 3, none of these being multiples of 5, and then you get your next multiple of 5, 5n plus 5, which is 5n plus 1. Okay? So, before each multiple of 5, Tanya lists 4 numbers. Okay? So, you got 1, 2, 3, 4. That would be before 5, but we don't write 5. And then 6, 7, 8, 9, and that comes before 10, but we don't write 10. Okay? So the number of numbers written for, let's say, the kth multiple of 5 isn't written is going to be, well, 4 numbers per multiple of 5, so 4k. So specifically for this question, we're asked about the 6th multiple, so that'd be 30. You could get 24. Now, this isn't the only way to do the question. Okay, it's a light bulb question, so you could just guess an answer, really. But you could also just sort of list them all out. I mean, it's not that many. Okay? I don't recommend doing it this way. You'll notice the way I did it, I mean, we're sort of jumping into a bit of theory. We're starting to understand what numbers are chosen and what numbers aren't. We have a bit of explanation there. But you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all the way up to 12, and then we get another set of 12 down here. So the answer is 24. But this, I mean, if they had asked me for before the 66th multiple of 4, well, I would be stuck writing for a very long time. We don't want to do that. We want to use our knowledge of how numbers work to simplify everything, and that's exactly what I chose to do here. Okay. So B, if the kth integer in Tanya's list is 2019, determine the value of k. Okay, so we just want to know what position is 2019 in. 2019, I'll notice, is just before 2020, which is a multiple of 5. Okay, so, well, how does this sort of work? 1, 2, 3, 4, these are the numbers before 5. 6, 7, 8, 9, these are the numbers before 10. 11, 12, 13, 14, these are the numbers before 15. I'm just trying to recognize a pattern. So these are the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th. Okay? So how are these numbers connected? Well, notice multiples of 4 are just before your multiple of 5, and that makes sense. For every multiple of 5, you get 4 new numbers added to your list. Okay? So we might say something like, we can see so each multiple of 4, or each multiple of 5 sort of brings 4 numbers to the list. Okay? We can also notice, we might even want to sort of prove by induction. So we notice that for, I'm not going to use k again, so let's say 5n, shall we? So that for 5n, the numbers we add are 5n minus 4, 5n minus 3. So I'm just adding the numbers that come before this. 5n minus 1, so in this case 4 or 9. Okay? And our positions let's see, the last one is going to be 4n. Right, 5 times 1, and this is the 4 times 1th position. 5 times 2, and this is the 4 times 2th position, this 9 here. So 4n, 4n minus 1, 4n minus 2, and 4n minus 3, respectively. Okay. So, how does that help us? Well, 2019 is 2020 minus 1, and that's 5 times 404 minus 1. So that's going to be my n value. And so it is in position 4 times 404. And that'll be 1616. And there's my answer, but I've explained things. In fact, we could sort of make the comment that 5n minus, let's say, r is in, I don't know why I wrote that arrow. So is in position 4n plus 1 minus r. Okay, so this is our observation here. 5n minus 1 went to 4n. 5n minus 2 goes to position 4n minus 1, and so on. So you sort of lose a value here. That's why we've added 1. So this rule right here tells me everything about where every single number would go. Now, if somebody asked me, oh, the number in this position is what? I can actually reverse this. Okay? We asked where did this number go? It goes here. Well, we can reverse it. I suspect that might even be what question C is going to ask me to do. Nope. No. Question C has something a bit more in mind. To determine the sum of the first 200 integers in Tanya's list. Okay. So sum of the first 200 integers in Tanya's list. So we're skipping out on multiples of 5. How far does this go? So 200th integer in the list is, well, let's see, 200 is 4n plus 1 minus r, thanks to my little observation. 200 is 4 times something. R will be 1, n will be 50. 4 times 50 is 200, add 1 is 201, minus 1 is 200. Okay, so I know I can work out sort of my last number. So we get 1 plus 2 plus 3 plus 4 plus 6 plus 7 plus... And then it'll be 5 times 50 minus 1. And so that'll be 249. And the numbers before it, 248, 247, 246. So this is the value I need to work out. Now, I think there's probably a couple ways you could approach this. I don't think any is necessarily better than the other. You could say, all right, I'm getting whole groups of 4. Is there sort of a formula or a general expression for this? I'm not going to pursue this particular way of doing things, but you'll notice 6 is 5 plus 1, 7 is 5 plus 2, this is 5 plus 3, this is 5 plus 4. So each group is your multiple of 5 the lowest multiple of 5, or the biggest multiple of 5 less than or equal to these numbers, and then plus 1, plus 2, plus 3, plus 4. Well, 1 plus 2 plus 3 plus 4 is 10, so we get a 10 for each group, and 4 times your multiple of 5. So, I mean, that's certainly a way to do things. So 4 times 245 plus 10 down here. So we could certainly do that. There'd be no harm in doing that. I don't want to do the question that way, but if you saw that, good for you. Instead, what I'm going to do is I'm going to, adding up these numbers is going to be kind of hard. So what I'm going to do is I'm going to add in the multiples of 5. Okay? So why am I doing that? So we'll add it. So 1 plus 2 plus 3 plus 4 plus 5. I'll add it in color in a moment. So 245, 246, 247, 248, 249. I'm going to add in 250 as well. And so I add in the multiples of 5. So now this is the sum that I want, but with the multiples of 5 added in. But now look at what we've got. We've got the sum of the numbers from 1 to 250. Now I mentioned in the very first video on the contest that they actually bothered to tell us in the question, or not in the question, in the contest towards the start of the paper, there's a nice little formula for the sum of the first n natural numbers. Okay? It's n times n plus 1 all over 2. So I know how to figure out this particular sum with these multiples of 5 added in. Okay? So that'll be 125 times 251. I'll just grab my calculator to make it easier. 125 times 251. 31,375. And you'd say, okay, that's great, but you didn't answer their question. You've got these multiples of 5 kicking around. And that's absolutely true. So the sum that I want is this number, 31375, minus, I need to get rid of the 5, I need to get rid of the 10, the 15, the 245, and the 250. Okay, we need to get rid of those numbers. But all of them are multiples of 5, so watch what we can do. We can take out a factor of 5. 10 is 2 times 5, 15 is 3 times 5. And look at that, I've got another sum of the first so many natural numbers, this time 50. So 5, and then it's 50 times 50 plus 1 all over 2. 31375 minus 50 will be 25. 25 times 5, 125. Okay. And then 51 times 125 is 6,375. And that'll be 25,000 when all is said and done. Okay. There we go. We got our answer. Managed to explain it using the nice sort of sum formula that they managed to tell us at the start of the contest. It was very nice of them. Okay. There we go. 25,000. And that's the last part for 3. Okay. So we're going to move on to question number 4 in the next video. I'm actually going to stick around here because I'd like to, show off the other way that I thought of and see, this method here. What can we do with that? Does it, it should get the same answer, but how different is it? Because I like showing off different ways to do the question. It's not just if you didn't see add in the multiples of 5, then there's nothing you can do. There are other ways to approach the question. So, if you want to stick around, that's exactly what I'm going to do. Okay, so we won't add in the multiples of 5 or anything like that. So I notice this is 10. The next group of 4 is 10 plus 4 times 5. So I already briefly explained that, but each of this is 5 plus 1, 5 plus 2, 5 plus 3, 5 plus 4. So we take their sum and we add on 4 5s. 11, 12, 13, 14. we get another 10, and we get 4 times 10. I guess technically we'd write this as 4 times 0 if we wanted to. Okay? And we're just going to keep going. 246, 247, 248. So those are all 245 plus 1 plus 2 plus 3 plus 4 plus 5. So we get the 10 from the 1, 2, 3, 4. And then we get 2 copies of 245. Okay? So how many groups have we got here? Well, it might be easier to rewrite these. Okay? So I'm going to write this as 10 plus 20 times 0. Because multiplying by 0 doesn't do anything. 10 plus 20 times 1. 10 plus 20 times 2, because 4 times 10 is 40. So I'm just taking out a factor of 5, so we'll get 49. So it looks like we've got 0, 1, 2, 3, 49. We've got 50 values over here. Okay, so the sum of Tanya's list, we've got 50 copies of 10. 1, 2, 3, all the way up to 10. And then we've got 20 times 0 plus 1 plus 2, all the way up to 49. So we get 500. I can ignore the 0. 0 doesn't do anything for us. And so we've got a sum of the numbers from 1 up to 49. So 49 times 49 plus 1, which is 50, divide by 2. So 20 divided by 2 is 10. So we're going to 500 plus 49 times 10 times 50 is another 500. So we've got 1 500, we've got 49 500s. That's going to be 50 500s, and that's also 25,000. So we get the same answer 2 different ways. One where we're sort of clever and adding in the multiples of 5, but this method of grouping by 4s wasn't bad either. And as long as we explain our work and our calculations, we're good to go. We'll get full marks. So that's 2 ways to do question number 3. Up next, we're going to take a look at question number 4. I'll see you there.